So our plan between now and the end is we're still using our books, so don't go and toss those, saying, sweet, we're done with those. We're just doing a little bit of review, and then there's one last little section that we have to go over in the book, which we'll take care of probably Thursday, Friday, and then we'll continue more and more with the review. Looks like the final exam is going to be 50 multiple choice questions. Now, I need to warn you of this. There are a few of the problems that have all the way to choice E, but the majority are only to choice D. Yeah, I'll give you a Scantron. So don't be the Chris Stirrup. Oh, look, E showed up, therefore it must be E. Does that make sense? Because there's a couple of them that will have an answer at E as well. Don't think just because you see now it has choice E that must be it. But let me run through the even problems real quick. Make sure we feel good about them. So problem number 2, you have 3x squared minus 5x plus 4 minus x squared plus 5x plus 6. So my friends, where's the biggest error that's going to take place on this? Yeah, you have this negative sign in which you have to distribute over the parentheses. You can drop this first set of parentheses. None of these signs here change. But then all of the signs on the right side of the parentheses, because I distributed the negative, change. And then you have to look and say, what do I have in common? You have to realize that is a negative 1x squared. So 3x squared minus 1x squared is 2x squared. And then those are like terms, so that's going to give me minus 10x. And these are like terms, so that gives me minus 2. And that's all it is. Okay? So just be cautious about that. Number 4, I would seem to help a lot. Oh, I'm sorry. Number 4, I was helping a lot of people with yesterday. And there was puzzlement on it. Between all of the sets of parentheses, there are only addition signs. Being that's the case, I can drop all of the parentheses on number 4. Can you see over my head? Okay. Grab a seat there, Cupcake. Here's your review. Open seating, pal.
Okay, this time I didn't do it.
All right. So on problem number 4, let's go ahead and just drop the parentheses. None of the signs change at all. Notice I rewrote it. I did not change any of the signs. They were addition between parentheses. Okay, so I have 7x squared because 2 and 5. Notice the exponents didn't change. These are like terms now. So that's going to give me, you have to realize there's a negative 1x, so I get negative 3x. And then I have these like terms. So 3 plus 9 is 12. 12 plus 5 is 17. Okay? And number 6, I can squeeze in down here. What do I do with number 6? I just drop the parentheses, combine like terms? I multiply. Do I double multiply? Yeah, so the x gets multiplied here and here. And the 3 gets multiplied here and here. So then I get x squared plus 7x plus 12. And that's my answer. Okay? Seem okay? All right. We feeling comfortable? We good? We feel uncomfortable, pal. Oh, sorry. Number 8. This is also a double distribute, right? Or a FOIL. So 3x gets multiplied there and there, so I get 9x squared plus 12x. And then distribute the negative 1. Don't forget the negative. Excuse me. Those are like terms. Combine those. And we get to there. Does this all seem okay? If you had these types of problems, especially as multiple choice, do you think you'd feel comfortable with the answer? I hope. Then number 10. This is another double distribute. Okay, so I'm going to distribute the x to both of those, so I get 4x squared plus 5x. Then I'm going to double distribute here. Oops. So that's going to give me plus 4x plus 5. Those are like terms. And that's what we do. Is there any questions about anything on that front page? Obviously, I went through the odd ones yesterday. But let's flip it over to the back side and make sure we feel comfortable with it. I do not recall either of these on the final. We good? Huh? Yeah. I passed it. I got a 61%. All right. I'm going to change up what I was thinking. All right. So let's go. I'm changing what I was going to do. Let's go to page 195. Page 195. One 195. There we go. Start browsing. Okay. Can you show me your page 195 real quick? Let's hold that up. EEF6, thank you. EEF number 6. Perfect. That's it. I wish I could do that too. I'm in. All right, so this is starting some of the last stuff in the book. This is on page 195. 195, yes. of our books. Okay, so it's exponents and exponential functions. Okay, not a real difficult thing. But exponents, they either grow or they decay. Okay, growth or decay. So, I don't remember what's on what page.
He was looking for you, and I just wanted to make sure he was right home.
Oh, he already showed up.
I know, but he wants to stay for the rest of the period.
Thanks for looking out for me.
Yeah, you bet.
Okay. So, the essential question, exponential functions on page 195. What do exponential functions look like, and what are some common characteristics of the graph? Okay, this is what an exponential function basically looks like. You could have something that looks like this, or you could have something that looks like this. Now, there are some other variations that do take place. We could have something that looks like this. We could have something that looks like this. These are all kind of what an exponential function is. It's something that kind of curves up or curves down. Okay? So that's what we have to do. And they have a basic iteration of y equals a times b raised to the x. And you have a starting point and a y-intercept at a. Okay? So this value here, what do you notice about, if a and b are numbers, what can you tell me about that first a? Does it have an exponent with it? No. Okay? The growth rate is b. B being the growth rate is what value that you have has the exponent with it. So if I had something like this, y equals 3 times 5 raised to the x, what would my starting point / y-intercept be? Well, that's my y-intercept. So the y-intercept is technically 0, 3, and this is my growth rate. Okay? Pretty simple so far, I think. Okay. Emmanuel out wandering the halls. Didn't bring his basketball, so he couldn't go to the hoop. All right. Okay. So step what? Page 195, probably 196 now. All right. Start at A, the y-intercept. Okay, so realize this is going to be 0, a. As you go to the right from A, multiply by B. As you go to the left from A, divide by B. Okay, so as I go to the right, we multiply by B. As we go to the left, we divide by B. Okay. I think we can deal with that. So 0, a is where it crosses the y-intercept. As you go to the right, you multiply by B. As you go to the left, you divide by B. Okay, right and left is just, right being this way, left being this way. Is that okay so far? Can I move on? All right. So these are all kind of graphs that we look like. So graphing y equals ab raised to the x. When our b value is greater than 1, it looks like either the red graph or the blue graph. When our b value is a fraction or a decimal that's between 0 and 1, our graph looks like the blue or the red, depending upon different things. Okay, so the red graphs on this would be, negative a times b to the x. The red graph here would be y equals negative a times b raised to the x. The blue graphs are written as y equals a b to the x. or y equals ab raised to the x. So basically, it flips over the x-axis if we have a negative a value. It gives something called a reflection. Okay? All right, so let's play with some of these. So we have this first one. So what did we say was our y-intercept? 0, comma, what value? 0, comma, a. So what is my a value in this equation? 4. So 0, comma, 4. We go right here. Okay? Does everyone feel comfortable with that? Now, I'm just asking you to survive on these a little bit. So I'm going to create a little t-table. So I already took care of the 0 x values because that's the y-intercept. So I'm going to plug 1 in. If I plug 1 in, that becomes 4 times 2 raised to the first power. So what's 2 to the first power? 2. So this becomes 4 times 2. What's 4 times 2? 8. So I have the point 1, comma 8. So 1, comma 8, 2, 3, 4, 5, 6, 7, 8. So now I want to plug another point. Okay, now if I picked a point to the right of the red, so if I pick 2, I bet you this is going to go off our screen. So I'm going to pick something to the left. What's a nice number that's to the left of 0 and 1? It would be a nice number between 0 and 1. Yeah, negative 1. All right, so this becomes 4 times 2 to the negative 1. Ooh, we have a negative exponent. What do we do with a negative exponent? What does it want to do? Do what? You want it to turn into a positive. How do I make that become a positive? What will make this, what would make that a positive? Do what? Parentheses, maybe. Any other ideas? So move it, change locations, right? So I'm going to change locations of the 2. Okay, change locations. So the 4 is going to stay up on top. I get 2 to the first on bottom. Hey, what's 2 to the first? 2. What's 4 over 2? 2. So this gives me the point negative 1, comma 2. So negative 1, comma 2. Now, this graph is going to look something like this. Okay? So we have a couple of new words that we haven't seen in a while. The domain, these are the x values. The domain of these will always be negative to positive infinity as far as this class goes. The range, though, this x-axis right here that I drew in green, I'm not going to go over. Okay, so this is in the y direction. This is 0, this is 1, this is 2. Okay, so my range is going to be a soft bracket. This is our y value. Soft bracket from 0, meaning I'm not going to cross over that green x-axis. But as I go to the right, it's continuing to go up in the air forever, so it's going to go to infinity. Okay, and these are kind of tougher to work on, so we'll be talking about these a lot more. So these are tougher to think about. Obviously, the domain should be a given because it's always going to be the same answer. The range gets a little goofier. Okay, so let's see if we can explore this a little bit more. Can I move on? We good? So now I have 2 graphs that we're going to graph. Okay, and I'm using survival mode. So I'm going to do this one in green, and I'm going to do this one in pink. So the green, we're going to take care of right here. So what number appears to be in front of the 2. So there's a 1. So what did I say my y-intercept was? 0 comma what value? A. So 0 comma A. So my A value on this one is 0 comma 1. Okay. Now again, we're surviving here. So I'm going to pick 1 and plug it in. So I get 1 times 2 raised to the first. What's 2 to the first? 2. What's 1 times 2? So this gives me the point 1 comma 2. Now friends, right now we have enough to graph our graph. Where are we not going to go over? So I got to draw that green line back in. That was our x-intercept. Okay, so right now that's going to work. So that means that this graph looks like this. It grows pretty rapidly. Yep. This other one we're going to do here, we're doing pink. So I didn't have to graph all of the things because, one, you told me it's not going to go over the x-axis. Okay, so I'm going to do this other one in pink right over here. So what's my y-intercept of our pink equation? What's our y-intercept? What's our A value? Remember, the equation's this. So what's my A value of the pink? 1/2, 0 comma 1/2. So you kind of have to squeeze it in. It goes down right down here. Okay. All right. Let's make ourselves a t-table. I think we still do this. X comma y. Let's see. Let's plug 1 in. So I'm going to get 1/2 times 2 raised to the first. What's 2 to the first? 2. What's half of 2? 1. So this is going to give me the point 1 comma 1. Oh. This other graph is going to kind of look like this. Okay. The domain and range of both of these is going to be the same. The domain is going to be negative to positive infinity. My range is going to be 0 to infinity. It's going up. All right. So I told you I'm not giving you a lot of homework, right? So we're going to continue this. We're not done with this lesson yet. So let us do, as a try, page 197. I think you can get away with 1 through 3. Six and 7. Okay, I bet you can get away with that. Okay, so 1, 2, 3, 6, and 7. Okay, we'll continue more of this tomorrow, but I'm giving you some time to work on that homework now. I bet you can get through them, and we'll go from there.